with me, Guy Royce. Hello, Internet people. My name is Guy Royce, and today I'm going to continue my quest to find haunted places using Redis and Apollo GraphQL. This time, we're going to add a little bit of search capability using RediSearch. So come on up, meet me at the Haunted Amusement Park, and I'll show you how I do it. All right, so first things first, I said RediSearch. I said the magic RediSearch words. And if I'm doing RediSearch, then that means I need to create indexes or indices. And I have actually done that already in the data loading code that I didn't show last time either. I've got this little load.js. You can run this. Instructions are in the GitHub repository. But the key thing I wanted to show you in here before we get started in adding RediSearch capabilities to our GraphQL Apollo stuff is I wanted to show you the index I was creating for places. So as you might remember, we've got haunted places. We've got cities that contain haunted places, and we have states which contain haunted cities. I guess all cities are haunted, and then contain places themselves. So you could, for example, get all the haunted places in Ohio, or all the haunted places in Columbus, Ohio, or you could go out and get a specific haunted place. And so I've created indexes for the cities, the states, and the places. We'll probably only use places on the video here, but I'll have all the code out there for you to play with on GitHub, of course. So here I'm creating using IO Redis, the index that we need here, the places index, which I'm shoving in this variable called places::index. I'm very imaginative at naming things. And so what we do here, it's pretty straightforward. We say, we add an index here, and I've got a little add index helper function way down here that says pipeline.call. So this is our Redis connection. I'm using pipelining because it's more efficient. We're calling ftcreate, passing in the index name. That'd be places::index. We're indexing on hashes as opposed to other types like JSON, which will be coming up really, really, really soon. And then we can give it a prefix of what we want that prefix to be. So that'd be the prefix on the key space. So in here, this is what I pass in here is place::. So anything that has place:: in front of it, index it for this index, any of those hashes. And this little one here just means that I'm looking at one prefix. I could look at 5 prefixes and then just use commas to separate those out. And then I give it the schema here. And then in my case, I'm passing in the schema as an array, and I'm destructuring it here. Not really as an array, but I'm using this spread operator here to take variadic arguments and turn them into an array. And then I'm using the spread operator again here to de-arrayify them so that I can pass in the rest of those arguments. And the rest of those arguments are instructions on how to index the schema. So in our hashes, we have location, we have description, and we want those both to be text. So that's like full text search. So if I just type in a random word or a word that I care about, it will return me all of the haunted places that have that keyword in it. So if I typed in like blue, it would give me all the stories about that have the word blue in them. And that's full text search. So if I used like the word give, it would also find gave and given and giving and stuff like that. So cool. I also have added the coordinates, and I told it that is a geo tag or a geo field. It contains geographical information, longitude, latitude as a string, and this will allow me to do geo searches. So I can say, give me all the haunted places within 25 miles of this particular location. Give me all the haunted places within 25 miles of Grand Central Station. And then I've got city and state here, and they're both tags. You can think of tags as kind of like an enum or like a tag cloud, a word cloud. So a tag would be, for example, in this case, it's all the city names and all the state names, or straight abbreviations would be tags. But you could also use tags for, just like a tag cloud on like a document. This particular document is, about JavaScript. And or this particular video is about JavaScript, and it's about Node, and it's about Apollo GraphQL, and it's about Redis, and it's about RediSearch. And so those would all be tags that you could search on. But they have to be the whole word. There's no like partial matching of the words, and they're separated. In our case, we're not using that multi-tag feature. We're just using the fact that city is either going to match or not in its entirety. So, and the same thing for state. So we've got those represented as tags. So that's the little index we've created to get this going. And this index lets us do a lot of particularly useful things. And so the first thing that it's going to let us do is actually find places. And so I'm going to add a couple of queries here. I'm going to add, as I look over here at my cheating code to make sure I'm doing the right things, I'm going to add 2 queries. Right now we can get place by an ID. We can get the city by the city and state. We can get the state by the state. But we want to get multiple cities. We're going to get places containing. So this is going to take a string that's required called text, and it's going to return all the places that contain that text, or with appropriate stemming and stuff like that. And it returns an array of places. And I'm also going to do places near. And places near is going to take a latitude as a float, and that's required. A longitude as a float, and that's required. And it's going to take a radius in freedom units, aka miles, and that is also a float. And it's going to return places, or place. So we've got 2 queries here, and then we're going to flesh them out here. We're going to make them do something real. But both of these are using Redis search, or will be at some point. So here we've got returning these arrays here. And this is something we haven't really talked about in the previous video. But let's go ahead and create a resolver that knows how to resolve these things. So here we've got our queries. So this is our place, our city, our state. And so we need corresponding resolvers here. And, our resolvers tend to be pretty similar. They all tend to have this, place, and then it takes all these same arguments and then calls a little fetch place or fetch city or fetch whatever. And this isn't going to be really that much different. So we're going to say places containing, and it gets the parent, the args, the context. And from the arguments, we want to get the text. We always need our haunted places data source. And then for our haunted places data source, we're going to add a find places containing, and then pass in the text. And then the find places near is going to be very, very similar. Places near. But instead of getting the text out, we want to get the latitude, the longitude, and the radius in miles. Oops. I just messed up my my cheaty code by hitting the wrong key. We'll go ahead. We want to get those guys there. So we're going to get the latitude, the longitude, the radius in miles. And then we're going to pass those in there. And it's going to be find places near. And so this is kind of what we've seen many times before as far as our schema and our resolvers go. This is, if you've watched part 1 of this video series, then you've seen me use this pattern before. So let's go ahead and do the interesting thing, which is implement the find places containing and the find places near. And so fetch place, fetch city, fetch state. Let's do, and then there's fetch. Let's do, I'm going to, again, look at my cheaty code here because I don't want to sit there and have you watch me type all this time. Instead, you can watch me look away and talk while I look for things in my cheating code. So we got find places containing and find places near. I have written these 2 little methods here. In my cheaty code, I'm calling a thing called find places, but I think I'm just going to call find. Just like I have these guys calling a thing called fetch down here. And it's going to pass in addition to the query, it's going to pass in the what do we call it? The places index. So it'd be places colon index. And I'm going to just double check that that's what I called that in my load script here. In fact, I think I'm just going to copy these over. That way I don't have to worry about it. I probably should put those in a separate file that they share, but I'm not going to do that right now. You can do that later with your version. So I can go to places index. Now I've got it in a nice little constant. And then this one will take places index. And what's going on here is we're passing in our query. So find places containing takes a query. For a text query, you just pass in the text you want to search for, and any field in the schema that's marked as text, it'll do a full text search on. So those are really very, very easy to do. For the latitude, longitude, and radius in miles, for the geo searches, our query string that's going to be handed to RediSearch is needs to reference the field name at coordinates. That'd be the field in our hash, colon, and then in square brackets, these 4 values that are making up the latitude, the longitude, the radius, and then the units, which I have hard-coded to miles, but we could replace those, for example, with kilometers or meters or whatever. But we're going to use miles. So that's what those queries look like. This is actually I think this is actually one of the coolest queries in RediSearch. I realize the full text search is very, very powerful, but this is the one I actually kind of like the most. And then I've got 2 little bits of code here that I'm going to pull over and talk about for that implementation of find. Here is find. It takes an index of query, and I had originally written this with a sort by, but we're going to take that out for now. I don't really care too much about whether that's there or not. That just says, sort the return values in a particular way. The client can sort the return values if need be. You can add sort if you want to. You can sort it in your resolver. There's lots of ways you can handle that. We're just going to skip the RediSearch doing the sorting for us right now. And so here we call find. It's got index. That'd be places colon index. We've got our query. That's either this string right here or just the text we're looking for in our 2 scenarios. And we're going to use redis.call, and we're going to say ft.search. That's the search command. We're going to pass in the index. We're going to pass in the query, and then we're going to give it a limit of how many it can respond with. It will get between 0 and however many you want. So you can do pagination. I've got a constant defined here, and I haven't defined it up top, and I'm going to go ahead and define it. And I'm just going to set it to a really big number that I know will work and make sure it returns everything. Because I know there's a little over 10,000 haunted places, and I think there's a comparable number of cities and states and all those combinations. We're not going to get more than 20,000 records back. And if you were doing this for production, I don't know that I would recommend doing exactly what I just did, because you might want to do something that's a little more paginated and a little more mindful. But this is just to show you how this works. So I'm going to do the simple cheaty stuff. So, but that's our call to RediSearch. Now, RediSearch, this ft.search, what it returns is just one big array. And that array consists of the count and then a bunch of individual items for each of the things that it found. And those things that it found are, there's count, then there's the key, then there's the value, then there's the key, then there's the value, then there's the key, then there's the value. And so that's an array that's structured like that. And I only care about the values. I don't care about the key. I don't care about the Redis key that it was stored in. I just care about the values that are in the hash. And so first thing I do is I get rid of the first argument here. I use the underscore count, or I could do just count, and then it'll gray it out and show you that I'm not using it. And then I use the spread operator again to say, get rid of the head of this list and just give me the tail. So this is really just separating out the head and the tail of this list. And then of that tail, of what's left in that list, I now have a key value, key value, key value. And so the keys are on the even numbers and the values are on the odd numbers because everything's 0-based. So all this little loop here does is it loops over that array and throws out all the odd ones or all the even ones. So if it's 0, then throw it out. And then we have to turn those values, which are themselves an array of keys and values, inside the hash. So instead of having, so it's like arrays inside of arrays inside of arrays. So I now have an array of arrays, and what I want is an array of objects, of JavaScript objects. So I use this similar in array to object. I take that array, which is set up in that same key value, key value, key value format. And I just say, give me list the keys, give me the values using that same filter technique. And then I use a little reduce function to turn it into a hash. So feel free to scrutinize this code on your own later. Let's just leave it at that it works for now. So we got a find, we got an array to object. This should be what we need to work. Let's see if it works. npm start. The server doesn't crash, always a good sign. let's go ahead and say places containing. Let me go ahead and refresh this. It's not connected. It usually gives me a little bit of a type ahead. There we go. Places containing text. And let's find places. Let's look for haunted Walmarts. So I'm sure there are haunted Walmarts out there. So we can look for that. And we want to get the let's get the ID of them and the location and the description. And let's get the coordinates, latitude and longitude. And then we can use those coordinates to come back and find other nearby haunted places next to those Walmarts. And then let's go ahead and get the city and its name. And let's get the state and its name and abbreviation. We can even get the state here as well if we wanted. I think I'm not going to do that. And this is actually one of the cool things about GraphQL is I told it how to find new places, but I don't have to tell it how to find the cities and the states within those places. It just knows how to do it already because it already knows how to retrieve places. And the way the resolvers work make this very powerful. So here we go. We got two results. We have Haunted Walmart here and the Forest Gallery Shopping Center, which is a former Walmart. I love this story here. It has been said that a lady wearing a Walmart uniform will be walking down one lane in the toys, and you will turn away and look back, and she will be gone. Later, you might see her down a different lane. So beware the lady in the Walmart uniform at the Haunted Walmart in Fort Worth, Texas. And here is the latitude and longitude of that Walmart. Here we've got another one that's in Tullahoma, Tennessee. It's just too funny. Cool. Well, let's use this latitude and longitude and make sure that our find near is working. So if we go to places near, in fact, we could do these right next to each other. Places near, latitude, and longitude. And a radius in miles. We'll say 25 miles near this Walmart. And let's just go ahead and get the same values back. And I have to get rid of that little space there. There we go. Okay, so places near that particular Walmart within 25 miles of that Walmart. Here is a Midway Recreation Center, Barber's Bookstore on 8th, Spaghetti Warehouse. There's a Spaghetti Warehouse in Columbus too. So yeah, you see there's several of them nearby. Cool. And one of them's called Lake Worth. I guess there's a Lake Worth in Fort Worth, Texas. That would make sense. So cool. That totally worked. It even worked the first time. That like never happens when I'm recording. So cool. So that's one thing you can do. But something that I think's particularly cool with the way GraphQL works is that we can also kind of go the other direction. Like I could add a places in Texas or a places in city or something like that, a places in state or places in city. But what I could do instead is I could just embed the places within the city. So instead of saying places, saying here's the places in the city and then getting all the places back, I could say give me a city and then tell me the places that are in it. And that's a more, in many ways, more intuitive way of doing it. So all we have to do here is add places, or place, and say that the city has places and it returns an array. And the same thing for an estate. For a state, it has places and it returns an array. And then when it comes time to our resolvers, we can go into our city and we can go down here to our city and our state and add a place resolver there. So I'm going to look at my cheaty code here. But again, this code is not going to be particularly brilliant. You've seen me do this kind of stuff before. So if I go to the city and get the places, we end up with just code that looks like this. Right? Go ahead and make that args. So we can see that it's grayed out. And so we got our parent, our args, our context. Our parent has is the city, and the city has a name and it has a state abbreviation. So we can get those two things. We can get our haunted places, and then we'll add a fetch places or find places for city. I think find, fetch, we're using search, so I'll call it FindPlaces for city, where we pass in this name of the city and the state. And then similarly, for states, where we want to do a very similar thing, we can do that. However, we don't have a state handler yet, so I need to add one, because the default behavior up to this point for states has been just fine. But here we've got, again, the same pattern, and we want to fetch places for state now instead. And then, excuse me. And then we want the abbreviation of that state, because that's the actual thing we care about. That's the key that we use to find states in here. And there we go. So abbreviation, find places for state. And then if we go into haunted places here again, we can say find places for state and find places for city. And I'm going to, again, use my cheaty code here just to make it a little easier for me to, well, you know why I use my cheaty code, because I'm a cheater. That's why I'm a cheater. That's what I do. Okay. So async find places. What did I call it? Called it find places for state and for city. Okay, so for city, and then be city and state. And then here we have async find places. We find places for city, find places for state. This would be the state. And all we're going to do, again, is the similar call here. And the difference is our query is going to be different. And so in the case of city and city state, here we just need to specify fields that we want to match on. So we want to match on the city and the state. So we have a city, which is in the places object. And we want to put that, since it's a tag, inside of curly braces. And then we want to put in city. And then the same thing here for @state, colon, and then in curly braces, the state. And so that will find places for the city state. And then find places for state is just going to be that part right there only. And so that should be all we need. Let's stop the server, try it again. And now what we should be able to do is say cities. Let's find a city. We'll go with Columbus. No, we'll go with Moonville. Moonville is no longer a city. It was never incorporated. It was an old city in southeastern Ohio, where there's an old haunted tunnel, and I've been there, and it's a delightful place to visit. And we can get the, of course, we can get the name of the city. We can get the state. We can get the name of the state and the abbreviation of the states. All that wonderful stuff that we always like to do. And then we can get the places in that city. And then for the places, we can get all the same fields that we've been getting all the other times, properly indented. Don't have to indent them, but I like to. And here we've got Moonville, Ohio. There's a deserted railroad tunnel and a Civil War graveyard, which is called the Moonville Cemetery. It's also up there. Cool, we found them. And so I can go for city, I can get the name of that city, the state, and I can get the places. What's interesting here is that we have the ability now to do a loop, right? So I can ask for the city of Moonville, Ohio, and then I can get the name and the state. But I can also use the state, because the state query now knows how to get places. And you could do that at this level here, right? We could say state and just put in Ohio. get the name and abbreviation of that state and all the places in it. And this is all the haunted places in Ohio that are in the data set. So lots and lots and lots of them. But because I have a state being returned in my place, I can get the places again. And you can go as deep as you want to go with this. Let's just go ahead and get all the IDs. And so now you see what's happening here is I'm getting all of them for Ohio, and it's still running, because then it's going through everyone in Ohio and getting all of them for Ohio again. And I don't know, there's probably hundreds of sightings in Ohio. Yeah, so it just finished. So that's actually quite inefficient to do it that way, right? You can see my actually my web browser has hung up a little bit as it's rendering. And so that is a flaw in the approach that we're using to do this. But you can do that. And you can get more clever with this. I'm going to fix this in the next video, because I don't want these videos to get too long, because you might get bored. But there's a way to, in your data source, to use a tool called Data Loader, which will not make multiple round trips, or not go and fetch the same thing multiple times from your data source. So we're going to make use of that in the next video. But for now, we've got this working. I'm going to go ahead and, there's a few more things I want to add to the schema, and they're not going to teach you anything new, so I'm not going to put them in this video, but I think they're worth having. Like, I think it would be nice to return all the cities in a state. Right? That seems worthwhile. And it would even be nice to have some queries where we can say cities and just get all the cities. And have a query called states that returns all the states. So I'm going to go ahead and finish writing those up and commit them up to Git so that you can check them out after you're done watching the video. But this gives us sort of a full graph to operate as. So, we can get cities, we can get states, we can get individual city, we can get individual state. And once we have those things, we can walk our object graph around, because our places have a state and states have multiple places. Our cities have multiple places, our cities have a state, our states have multiple cities. And so there's a graph here that we can walk around. And this is really makes that graph complete. This is why it's called GraphQL, because it lets us walk that object graph. So I'm going to go ahead and add those capabilities. But until then, thanks for watching. Do the obligatory like, subscribe, and all those things. And if you have any questions, of course, leave them in the comments below. And until then, thanks for watching. I'm going to go write some more code. With me, Guy Royce.
Right in the corner. Ah!